Classification of elements. Why the elements are classified? Actually, there are so many elements and having different type of properties. Some elements are having same properties. So to learn about in sequence, so elements are classified in different manner. So starting onwards, there are so many attempts are made for classifying the elements, and some classification models are failed, not properly explained. Some classifications are explained. So we will discuss about this classification of elements here. The method of the method of grouping elements into different classes is called classification of elements. So many attempts have been made to classify the elements. So starting onwards, there are so many attempts are made to classify the elements. So those theories are: number 1, Berzelius classification. Second one is Proud's hypothesis. Third one is Daverner triads. Triad. Fourth one is Newland's law of octaves. Fifth one, Lothar-Meyer atomic curves. Lothar-Meyer atomic volume curves. So these are the classification made at starting, and one by one we can explain about this. So now first one is Berzelius classification. So Berzelius explained about elements based on metals and non-metal concept. That means he classified the elements into metals and non-metals based on the configuration, acidic properties, basic properties, valency. So, but all the elements are not metals, and all the elements are not non-metals. Some other metalloids also possible. So finally this is failed. So he given some little bit explanation about that. So what is that explanation is, he classified the elements as metals and non-metals. And this classification is based on based on valency. Second one is acidic and basic nature. Acidic and basic nature. Then electronic configuration. Electronic configuration and electrochemical behavior also. Electrochemical behavior. So students, Bergil is classified the elements as metals and non-metals, and this metals and non-metals classification is based on valency and its acidic and basic nature and electrochemical behavior. But he classified the elements into metals and non-metals only. But all the elements are not metals and non-metals. Some are metallites also possible. So finally, this theory becomes failure. Second one is Proud's hypothesis. Proud's hypothesis is just imagination. It is just an imagination to classify the elements. Actually, this Proud's hypothesis is based on hydrogen atom, which is a fundamental unit. He considered as a hydrogen as a fundamental unit. So considered hydrogen as fundamental unit. Fundamental unit. So all the other atoms are made from a hydrogen. So he considered all other atoms are made from hydrogen. So this is also known as unitary theory. But just he given some assumptions, and that's all. No other classification of elements. Hence, this theory is a failure. Actually, this is just a hypothesis, just imagination only. He considered the hydrogen atom is the main fundamental unit, and all other atoms are made from a hydrogen atom. And this is also known as unitary theory. But he did not give any classification. So hence, this theory is a failure. So triad means three elements in a certain group. Three elements in a certain group having similar properties when the elements are arranged according to their atomic weights. Actually here, if you take any three elements in a certain group, first element and the third element atomic weight is, if you take average, then we can get the middle element atomic weight. So that is nothing but law of triads. So here main basic concept is when elements are arranged according to their atomic weights, when elements are arranged according to their atomic weights, by taking three elements in a certain group, the average atomic weight of first and third element is equals to the atomic weight of second element. So here we will take one example, then I will explain, students. Here take 1A group elements So for example, lithium, sodium, potassium. So lithium atomic weight is 7, potassium atomic weight is 39. Take average 7 plus 39 by 2, 46 by 2, 23. Calcium, strontium, barium. Calcium, strontium, barium also. Here atomic weight of calcium is 40, barium atomic weight is 137. So if you take both 40, 137 average, we can get 88. So 88 is the average value of calcium and barium atomic weights. Then that is nothing but strontium atomic weights. Similarly, chlorine, bromine, iodine also. So chlorine atomic weight is 35.5, iodine atomic weight is 127. So its average is nothing but atomic weight of bromine. So actually, by moving one group to another, by moving from up to down, variation will be, some more variation is there. So due to that variation, and also it is not applicable for all the elements, so hence this theory also not successful. Next one is Newland's Octave's law. So actually, why they called octaves means, so in Indian music we have so actually this Sarigama Padanisa is 1, 2, 3, 4, 5, 6, 7, 8. Actually, first one is repeated as a 8th one. So that's why they are given as octaves. Oct means 8. Oct means 8. So first one and 8th one is repeated. Similarly, when elements are arranged according to their atomic weights, first element and 8th elements are having similar properties because they are in a same group. So that is the Newland's law of octaves. So here, when I'm writing main point, when elements are arranged, according to their atomic weights, first and 8th element are in a same group and having same properties. So example, if you take one example, so actually we can take hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, boron, aluminum, carbon, silicon, hydrogen, phosphorus, oxygen, sulfur. So here chlorine, potassium, calcium. See the students here, consider this is first one, lithium is first one, then beryllium second one, this is third, fourth, fifth, sixth, this is seventh one, this is 8th element. See the students, first element and the 8th elements are in a same group. Same group means they are having same properties. So normally elements present in the same group are having same properties. If you take beryllium as a 1, then magnesium is the 8th element. Then beryllium and magnesium are having same present in a same group, same and having similar properties. Similarly, if you consider carbon as the first one and the silicon is the eighth one, then both are present in the same group and having same properties. So when the elements are arranged according to their atomic weights, first element and eighth elements are present in same group and repetition of properties are possible. But it is possible, but it is a failure because after 20 elements it is not possible. So this law failed. In case of elements, after atomic number 20, so this theory has failures. Lothar-Meyer atomic volume curves. Actually, this classification is based on curves. That means that curves is between the atomic volume and atomic mass. So this classification is made. Classified the elements based on curves between atomic volume and atomic mass. So actually he given one statement also, because he explained the classification of elements based on periodic functions of their volumes. So here he calculated the atomic volumes. He calculated the atomic volumes, calculated the atomic volume based on atomic volume equal to molecular mass by density, molecular mass by density. So he given a periodic law. So what is that periodic law? Is the physical properties of elements or periodic functions of their atomic volumes. Because based on atomic volume we are explaining all the properties. So physical properties of elements follows the atomic volume. So based on this we can draw curves, Lothar-Meyer atomic volume curves. Here So students, here this graph is drawn based on x-axis atomic mass is taken, atomic mass, on y-axis atomic volume is taken. So here this is lithium, this is beryllium, this is carbon, here magnesium Mg, here sodium, here potassium, rubidium, cesium. Actually here lithium, sodium, potassium, rubidium, cesium, here beryllium, here magnesium, here calcium, strontium, barium. Next here aluminium, here chlorine, here bromine, here iodine, next this is calcium, copper, zinc. So here copper, zinc, here ruthenium, rhodium, here ruthenium Ru, rhodium Rh, Cd cadmium, here barium, here lanthanum, so students, this is the graph students. Based on this we can explain. Actually this is the peak point. See the students, peak points. So this is nothing but the maxima of curve. Maxima of curves. Maxima of curves is occupied by alkali metals. Alkali means 1A group elements. So alkali metals 1A group elements occupy the maxima. Then what about minima? Minima of curves. So minimum is there is a, see this one. So actually minima, the minima actually here peak positions 1A group elements are occupied. So top to bottom means decreasing portion, bottom to top peak point means increasing portion. So here 4 points are there at minima. See this copper, zinc, ruthenium, rhodium, these are the minima. So transition elements are D black elements. So D black elements occupies the minima, and decreasing portion of a curve is occupied by, decreasing means top to bottom. Take top to bottom, this is the 2A group elements. 2A group elements means alkaline earth metals. Alkaline earth metals occupies the decreasing portion, and similarly increasing portion of a curve, that means bottom to top halogens are present. See that here. So I am giving tick mark. Chlorine, bromine, iodine. See this. This is the increasing portion. So that means down to top. That is the increasing portion. So increasing portion is occupied by the halogens. Halogens. Fluorine, chlorine, bromine, 7th group elements. So alkaline earth means 2A group elements. So D black. So students, here we should observe the mainly 4 points. Lithium, sodium, potassium, rubidium, cesium, 1A group elements, alkali metals occupies the maximum of a curve. And beryllium, magnesium, calcium, strontium, barium, 2A group elements, alkaline earth metals occupies the decreasing portion of a curve. And halogens, chlorine, bromine, iodine occupies the increasing portion of a curve, 7th group elements. Minimum is down. So D black elements, transition elements occupies the minima of a curve. So these are the 4 points, students. So based on that, he explained the different elements classification,